Okay, so good day, grade 8 math science students. For our fourth lesson, we're going to be discussing about similar polygons. Okay, so what you're seeing here on the front, okay, so on the screen, there are similar polygons that can be found on different portraits or paintings that can be made digitally. So for example, we have this painting of a cat right here. So it uses similar polygons or similar triangles in order to create this picture. And also we can create other art materials or other art made pictures and portraits out of similar polygons. So if you also notice, if you explore different graphic software like Adobe Photoshop and other or other photo editing software, you can create what they call this, different patterns for different types of polygons, especially for triangles, since triangles only have 3 sides. So there you go. So for this one, it's a cat that has been shaped from different types of triangles. And also we have here abstract patterns for this looks like a stained glass, and this one is an abstract shape. And also for this one, this kind of looks like an illuminated polygon from also a stained glass. And of course we can draw simple polygons such as a stoplight, which is shaped like an octagon. Okay, so those are some real-life examples of similar polygons. Okay, so what is a similar polygon? Or what are similar polygons? Similar polygons are any polygons that have the same shape but do not necessarily have the same size. So when we're talking about congruence, okay, so when it's about congruence, okay, so when we say that two shapes are congruent, they must have the same size, and they must have the same shape. But if we say that two polygons are just simply similar, okay, so they only need to have the same shape. Okay, so they do not necessarily have to have the same size. Okay, so as opposed to the symbol of congruence, okay, so the symbol for congruence is an equal sign with a tilde mark on top of it. Okay, so for the similarity symbol is just a tilde. Okay, so there you go, between the two figures. So the symbol for the similarity between the two polygons is simply the tilde. Given the two polygons on the figure below, we can say that pentagons GRAND or grand and SOUTH or south, even if they have different side measurements or sizes, since they have the same angle measurements, okay, that therefore the small pentagon GRAND, it's been what to call this, scaled to a larger pentagon SOUTH. Okay, so they might have different sizes, but they are very much similar to each other because they have been scaled. Okay, so two polygons are also said to be similar if and only if their corresponding angles are congruent, okay, and their corresponding sides are proportional. So given on the figures GRAND, okay, and okay, so the other one is south, okay, so these corresponding angles are also congruent based on the shade of blue color on the illustration. Okay, so there you go. So we also have a lot of similar polygons that can be found on real life objects such as this one. So we call the ratio of the measurements of the sides of two similar polygons as the similarity ratio. The similarity of each pair of corresponding sides of the two polygons may differ depending on the length of the sides, but the ratio stays the same. Okay, so for this one, the golden ratio, the 1 is to 1.618, so it stays the same for these types of portraits. Okay, so this can also be seen on bond papers. Okay, so there's a lot of application for the value of phi. Okay, so as a form of review, remember the golden rectangle. So the said rectangle contains the golden spiral, which outlines the mystical ratio called, of course, the golden ratio. The mini or the tinier quadrilaterals found inside of the golden rectangle are all similar. So all of the squares found inside of that rectangle are all similar to each other. They are similar polygons per se, or because they are polygons themselves. Okay, so there you go. They might have different size measurements, so one square might be bigger than the other, but all of those squares have similar ratios and they are similar to each other. Okay, so the similarity lies, of course, on the given ratio, which is the golden ratio, the value of phi, which is equal to 1 plus square root of 5 all over 2. So in his book, Leonardo da Vinci mentioned in the divine proportions, okay, so he outlined or explained the idea of the golden rectangle. So there you go, you're going to find more information about the golden rectangle when we read or if you read one of Leonardo da Vinci's works. Okay, so we have here word problems involving similar polygons. So the case for similar polygons, in order to make it more clearer, similar polygons are only so similar if and only if their corresponding angles, okay, their corresponding angles are congruent. Okay, so the angles, okay, corresponding angles must be congruent, and their corresponding sides, okay, their corresponding sides must be proportional. Okay, so that means, for example, we have here triangle, square ABCD, and we have here a smaller square EFGH. Okay, so therefore we can say that these two squares are, okay, so let's say they're rectangles. Okay, so let's say that rectangle ABCD and rectangle EFGH. So we can say that AD over BC, okay, is proportional to EH over FG, because we know that their angles, okay, their corresponding angles are all congruent, and also their corresponding sides are proportional. So if we have your AD over BC, it's proportional to EH over FG. Okay, so let's try to have some applications of this problem. Okay, so Liana wants to cook a triangular shaped shawmai or dumplings. Given the top view of the illustration on the right, find the value of P and the measurements of GE, EM, AN, and NU, given that angle G and angle A are congruent and the two figures are similar. So given that the two figures are similar, we can say that GE over EM is equal to AN over NU. And from here, we can solve for the value of P. So this is going to be equal to, since G is equal to P plus 6, so we can write that P plus 6, all over EM, which is 18, is equal to AN, which is equal to P plus 2, all over NU, which is equal to 12. And from here, we can do cross multiplication. So this becomes 12 times P plus 6 is equal to 18 times P plus 2. And if we distribute 12, so that gives us 12P. Okay, and 12 times 6. 12 times 6 is simply 72. Plus 72 is equal to 18P. Okay, and 18 times 2 is simply equal to 36. Okay, so that gives us 72 minus 36. 36 is equal to 18P minus 12P. So that will give us 6P is equal to 72 minus 36. That will give you 36. And divide both sides by 6. Therefore, the value of P is simply equal to 6. And from here, we're just going to substitute the value of 6 for P. Okay, so 6 plus 6. So therefore, EG is equal to 12 centimeters. And therefore, this is 6 plus 2. So this becomes 8 centimeters. Okay. Okay, so there you go. We have the value of EG, okay, or GE, and then AN, okay, and we also have EM and NU, and the value of letter P, which is equal to 6 centimeters. Okay, so let's try some other problems. Let's try this one. Okay, so we have here Jessie wants to create her own miniature earring boxes given on the blueprint below. So on the blueprint are also the measurements of the said boxes. So given that the polygons below are rectangles and are similar to each other, so that's very important, this clue here. Since they are similar to each other, we need to find the value of A. Okay, so to solve for the value of A, let's try to first create a formula to solve for the value of A. So we have here AT all over TR can be equal to, okay, so since it's named as PATR, okay, so and this one is named as FN, FN, okay, FNDI. Okay, so therefore we can say that it's equal to ND all over DI. Okay, so what's the value of AT? AT is equal to 4A plus 12, and TR is equal to 19. So it has to be equal to ND, which is equal to 3 pi all over A, and DI, which is equal to 7. So we just cross multiply, so that's going to give us 7 times 4A plus 12 is equal to 19 times 3, okay, 3 pi A. Okay, so there you go. So we can distribute the value of 7 here outside of this parentheses. So this is going to be equal to 28A plus, what's 12 times 7? So that's going to be 84, right? 84 is equal to, okay, so 19 times 3, that will give you 57 pi A. Okay, and therefore we transfer 28A to the other side. So this gives us 84 is equal to 57 pi A minus 28A. Okay, so 57 pi. So 57, okay, 57, okay, 57 pi minus 28, so that'll give you 151. Okay, so 84 is equal to 151.07A. And if we divide both sides by 151.07, we get that the value of A, okay, the value of A is equal to 0.56. There you go. So this is the value of A. And essentially, we found the value of A. Okay, so that's 0.56. So to solve for the value of AT and ND, okay, so that's going to be AT is equal to 4 times 0.56 plus 12. And ND is going to be 3 pi times 0.56. So we have here 0.56 times 4, okay, plus 12. So the side measurement AT is equal to 14.24 centimeters. And for ND, we have here 0.56 times 3 pi. Okay, so that's going to be equal to 5.28. Okay, 5.28 centimeters. Okay, good. So let's proceed to the next one. We have here Selena wants to create a cool sticky notes for her wall pin board in her room. Given that the sides of the sample sticky notes are on the right, so let's try to solve for the value of x. So therefore, that's going to be NU over WR is going to be equal to IN all over TB. So since NU is equal to 3x plus 1 and WR is equal to 8, this can be equal to IN, which is equal to 15, and TB, which is equal to 5x plus 7. And from here, we can do cross multiplication, and automatically you can see that this is going to give us a quadratic equation. Okay, so this gives us, okay, 15 times 8. So 3x times 5x, so that's going to give you 15x squared. Okay, and then we have here 5x, and then we have here 7 times 3, so that's 21x. Okay, so what's 5 plus 21? So that's going to give you 26x plus 7 is equal to 15 times 8, so that's equal to 120. So therefore, if we transpose 120 to the other side, so 7 minus 120, so that will give you negative 113. And from here, guys, you can use your calculators or any online calculator to solve for the value of x, or you can also use the quadratic formula to solve for the value of x here. So we'll have, okay, so the solutions are x sub 1 is equal to 2.01 centimeters, and x sub 2 would be negative 3.74 centimeters. And since we cannot have a negative value for our x. So therefore, the value of x is equal to 2.01 centimeters. Okay, and if we substitute that, that's going to be 3, okay, times 2, so that's 6. So this will become 7 centimeters. Okay, so this is 7 centimeters, and this is 17 centimeters.